Hey there. So yesterday, one of my coworkers shared this tweet with me from Jake VanderPlas, asking about this 4-line little code snippet. He actually framed it as a quiz. I've cut off the options because the quiz is over and you would actually see the answer. And I think that's less interesting. But yes, so I actually got this one wrong. And not just me, actually several of my coworkers and students, I think also might have been misled by this. Maybe not misled, but might have guessed incorrectly on this. So I think this example from Jake VanderPlas points out a few really important, actually, edge cases from edge cases within the Python language. So I tinkered a little bit yesterday after I realized I got the answer wrong, and figured out kind of the most important parts to understand, to really see why this happens the way it does. So I wanted to explain those. Jake has a little bit of an explanation actually in the Twitter thread if you want to follow up there, but it's just in text. So I wanted to actually explain this using a Jupyter notebook so that everybody can see. So I'll restart everything real quick so that we can start fresh. So just to start out, I want everybody to sort of think about what you would expect here. So some of the examples that were put in, one of the examples was, 1 comma 1. So it might print just a modified empty list with a single 1 in it, followed by a modified empty list with 2. It might be 2 of these with just 1. Turns out though that both of those answers are incorrect. So let's actually see before we even get started exactly what happens. So here we have this simple function that takes the input, which we set that default argument to an empty list. It appends 1 to that argument and then returns it. So here we actually have both parts of the output, both parts of the print statement returning length 2 lists, 1 and 1. Okay, so I said there's 3 really important things to understand in order to see why this is happening. The first one is actually the one that Jake left out. I believe I would guess that he left this out because if you're the kind of person who is entertained by Python edge cases, you might be very familiar with this. I think this is sort of typically a topic that is found in many Python introductions, though it is very easy to miss. And I've seen very senior people who've been working with Python for years mess this up, and even myself. I tend to think of myself as being very familiar with Python, and I actually miss this even though I know how it works and I could describe it on a whiteboard in a job interview. And that's just because it works a little bit unintuitively. So I want to explain how mutables work with variable assignment. So the typical way to explain this is to start with something that is not mutable, so like an integer. And all that means is that here we're assigning the value of 3, the integer value of 3, to the variable a. We take a and then assign its value to b. So we have 2 variable names, each pointing to the same value, 3 and 3. Now, when we take one of them, either a or b, and we modify the value for that variable, what do you think happens? Well, the most reasonable thing is that b would be modified and a would not. And that's exactly, Python follows our intuition very precisely there. It would be strange for a number of reasons if that didn't happen. But so let's remember that and then look at what actually happens with a different kind of data type, the mutable data types. So we'll use list. It's maybe the most common, one of the more common mutable data types in Python. And all mutability refers to is just the fact that we can actually change a list. So previously we were pointing to a specific value, the integer 3. In this case, when we set a to be equal to this list that contains an integer, we're not actually setting it to a single value. A is instead instead pointing to an actual sort of an object in memory. And that object is this list with 3 in it. So what that means is that when we set b to that, so this works as expected. So when we set b equal to a, what's happening is that instead of sort of making a copy of it or sort of assigning a value the way that we did earlier, we're actually going to, with b, it's going to be pointing instead to this very first list that a started with. The reason that very subtle distinction is important is because here, when we modify b, we're not modifying a sort of static value. We're modifying the object that b is pointing to. And a and b happen to be pointing to the exact same object. You can think about how strange that would be if it occurred with integers. If whenever we updated the integer value of b, we actually modified what the number 3 means, that would sort of mean that we could no longer do math in any subsequent lines in our programming language. So that it makes sense to not, in this case, that modifying b does not modify a. But here, we're dealing with something sort of qualitatively different when we're dealing with mutable values, and that's very important. So another thing that you can do actually to verify this, to sort of ensure that you understand what's happening, is we can actually add these ID statements or these ID functions to actually inspect the variable and look at the identifier for where that is pointing. So let's look at the ID for A and the ID for B here. So let's go back and run this to get a fresh start. And so we can see here that these are equal. We can verify that they're equal here, true. So that's great. That's as we would expect. They're sort of both pointing to the same value. But let's copy this cell and then insert it below here. After we run this line, these lines that are modifying one of our variables, we actually get different values, and then we can verify that again. This is now false. Okay. So if we do something very similar to our lists, in our list situation, so let's add this cell here. Again, we have the same value. And let's think, let's take a second and think critically about what do we expect this to be here? So in the integer example, when our variables were all being set to integers, we actually changed from having the same ID for both variables to a different one. In this case, what do you think it will be? So let's run all of these in order to make sure that this all works exactly as we think. And if you said you think that the IDs will actually remain the same, you would be right. So this is sort of just another way to verify that what's happening here is that A and B are just pointing to the same object in memory, and that object is the thing that's being modified, not a value updated, as is the case with immutables. So, okay, so that's the first really important thing to understand. That gets you part of the way into understanding this behavior. So we can see that when we modify mutables after we assign them, that modification carries over to every variable that points to the same object. But there's still a few curiosities here that I think that doesn't fully explain. So let me start with one of them. One of them is that we would typically expect functions, when we have a default argument for that function, to behave similarly whether we explicitly sort of reiterate that default argument and set it manually versus not. And so we can verify that behavior with integers. So here, in this case, we're doing sort of addition on integers, and I'm explicitly setting that default value of 3. I'm just sort of repeating what I said in the function definition, being a little bit extra here. Then I can verify also integers are nice and intuitive in this way. This still works if we don't set it. So we get kind of the same behavior whether our arguments explicitly are identical to how we define the function or not. Here, this is a little bit different on the other hand. In this case, we're going to use lists instead of integers, and we're going to remember everything that we just learned about when variables are pointing to a list object. And so in this case, this is the behavior that we get if we sort of explicitly set the arguments for each function call to the same set of arguments that we see in the function definition. We each get a single item in a list. What happens, however, if we omit that setting those arguments explicitly? In this case, what happens is the first function call is actually modifying our variable, the object that it's pointing to. And then it seems the second function call is not actually assigning that variable again. And it seems to be modifying that very same object. So we can keep running this and running this and running this and just see that, of course, our underlying variable keeps getting modified over and over. So what's happening here, it's a consequence of the way functions are actually implemented in Python. So when we implement a function, I'm going to add a few cells here. When we, sorry, not implement, when we define a function, what happens is we take this name of the function name of f, and then we build a function object out of it. And we sort of populate that object with all the things the function needs to run. We can verify that it is in our global namespace. Oh yeah, globals, apologies. So we can scroll down, peeking ahead. We can scroll down and we can find our function here. So now that we've defined that function, we can see it in our global namespace, and we can use all of the Python's built-in tools to actually understand and inspect the function. So we can say, hello function, what is your type? It is the type of a function. We can look at the help information on it. We were lazy coders here. We didn't actually add any doc strings or anything, so the help function is very minimal. But if we had a doc string, help would actually include that information. So in this case, f is our function object. And included in that function object, I'll keep that here. Included in that function object is this secret property or hidden property. Hidden properties are designated with these two leading underscores. So there you can actually see that this is where the function keeps our default values. And as before, when we set a variable of any kind to be equal to a mutable object, it is going to point to an object in memory. It's not going to point to a value. So hopefully it sounds like I'm a broken record now. It is. I realize it's a little bit repetitive, but it can be so unintuitive. And that's really the cause of these errors, is that the sort of unfamiliarity with that concept. So what's happening here is when we define our function, it is only setting those defaults a single time to that object in memory. So we can verify this actually by taking the code that we ran above here, where we execute that same function twice. We can take that code and modify it a little bit by preemptively updating our default and then seeing what happens. So here, what's happening, let's just run through this line by line. We're going to define a function named f, and we're going to set that default value equal to this empty list. We're going to talk about what the function is actually going to do. And then after that, we're actually going to reach into this, this hidden property. We're going to grab that default value, that empty list, and then we're going to append something to it. So we now understand what's happening, so we're going to append haha, because we're getting better at this. And we can see actually that what happens here is that every time we run the function f without actually explicitly setting those arguments, it goes back to that default argument, which is just this object in space. So now we can verify that this has actually been changed, those defaults, by inspecting that again, and we can see, yes, the output here is actually just this modified empty list. This object that started out as an empty list, we've modified it once by hand and then twice through the function, and now this is the output. So those are the two most important pieces. However, there's one last, I think, really interesting part of this, and it's it is basically understanding why this code, where I'm printing once and then a second time, this is sort of very carefully been modified from the initial example from Jake VanderPlas to illustrate a point. So that point is that when we combine these into a single print statement, we actually get different behavior. And the question is why? So again, I'm going to start with kind of a counterexample. If we go back in time to Python 2, this is a version of Python you should not be using. It is no longer supported. I normally don't teach it. I don't even have a Jupyter kernel that runs it. So I had to find somebody else's tweet who ran it and include a screenshot. So we'll just take their word for it. But what happens here is that if we run a print statement without the parentheses, what happens is we actually get a different value for the first function call and then the second. So why is this? Why is it different? So to answer that question, we sort of have to understand how functions work. When a function actually includes as an argument function calls, so the argument is equal to the output of a function. What happens is it's going to execute both of those individually first before it then runs that function. So we can see here now, if we actually put both of these on the same in the same print statement, unlike above, now we can replicate that behavior where we get the same output. All right, so those are the three sort of gotchas, the three tricks. Yeah, thanks for